welcome everyone to tonight's training, our final training of 2019. Very exciting. We're glad you're attending online and in person. And if you're not attending in person, you guys missed on some bomb chicken enchiladas, man. Those are really good.
I'm going to eat mine after.
Yeah, good job, Doug. Real quick, we're going to do some housekeeping things. Gary Crosby is here from Resideo Honeywell. He's been here before. Gary's been in the industry, used to be a tech. He's brought that knowledge to Honeywell, and by far one of the most likable people on the planet Earth. And we're going to talk about IAQ today. Real quick, the housekeeping items are, if you have any questions, do you want to go to the next slide?
I can. Ooh, see that peel away?
See, look at that, a cool transition. So there's some areas for you to interact with Gary if you are online. You can ask questions in the Q&A box, and we'll relay that to Gary, and he'll get to that as soon as possible. There's also some slides, there's some polls in there, a survey, a speaker bio. I'm actually interested to read that. I want to see
Mine's weird. They make this stuff up.
And then some just general questions at the end. But this is meant to be interactive, so if you are
2
online,
hours of Nate credit. So
2 hours.
If you're Nate, sign up online or out here.
Yes,
okay.
This is a Nate accredited course.
Just do it in 45 minutes.
Yes, do it in 45 minutes. Gary, welcome. But that's all we have there. Like I said, ask as many questions as possible. That's what we're here for. It's interactive.
Cool.
Same with the people in here. But to Gary, I know you got a big training, so I'm just going to let you
Yeah,
go
man.
ahead and take it. Thanks for coming. Give Gary a round of applause, everybody.
Yeah! What's up with that, man? All right, so end of the year, right? So Jackson Systems, big part of my number, and I always appreciate what you guys do for us and in our heating and air community. So big thing. Had lunch with the famous Ron Jackson today, which is always fun, and he's just a great guy. So if you ever stop in, if you're ever local and you stop in, if you've never met Ron, the owner, the guru, meet Ron. He'll loves to talk about heating and air, doesn't he, Tom? So, and he's forgotten more than most of us will ever know. So I love that guy. So we're going to talk about IAQ because even the most seasoned technician fumbles with IAQ a lot, right? Because we don't want to get in front of a homeowner and look stupid, do we, guys? And if you don't fully understand these things, that's the biggest barrier for a technician to try to promote that product that a homeowner really needs. Like humidifiers work, don't they? Right? But if you put them in incorrectly, they don't work very well. And if you don't maintenance them every year, they're not going to work, right? And I've seen humidifiers that were put in, and 5 years later, nobody's ever touched it, and you got to chisel that pad out of there or just replace the whole thing. So these things, you can't just put them in and think that they're going to run forever unmaintenanced, right? So not only do they help you make more revenue by something to sell to a homeowner that they're going to pay you to do, but it's going to be recurring revenue for your service department because let's face it, we're in business to make money, right? And we make money by serving our homeowners by keeping their indoor environment where it needs to be, right? Whether it's heating and air or IAQ, and IAQ is a big part of it because the plumber cannot do anything about their indoor air quality, right? The electrician can't either. This is a function of the heating and air guy, right? And most homes have a problem, right? And sometimes they're identifiable, sometimes they're not, right? Now, we're not going to go over we've got a product that we partner with Air Advice, and we've got a really good training regiment with Air Advice monitors that we call Air Cycle Pro, and it's a monitor you can put in a house on a service call, and in 30 minutes it emails a detailed report of everything that's in the air, chemical-wise, particulate-wise, humidity, temperature, and explains to the homeowner that it's either in the safe zone or not, right? Or in the air cycle, so to speak, or not. And then it tells you at the end of that report which one of the Honeywell Home Resideo items to go get off your truck to solve the problem for the homeowner, whether it's, high or low humidity, or I've got a bunch of chemicals floating around in the air, I need to take that out, or I've got really bad ventilation and I need to put that in. So most of the contractors that I go and see, very few of them are doing any ventilation at all, right? I mean, it's the most misunderstood part of our business, but HVAC stands for heating, ventilation, and air conditioning. And 99% of the time, we're just doing heating and air conditioning, right? So as these houses are spray foamed, we got to start putting mechanical ventilators in them, which is an ERV. And actually, spray foamers buy more ERVs from me than heating and air guys, and that's just not the way it should be working here, okay? So we'll go through all that. But when you're on that service call and some of the hardest things to do is break the ice with that homeowner, right? So this is usually where you're going in there, you're trying to find out by asking a few questions about what's going on around here, and do you have any hot and cold? There's a couple of questions you ask, right? But if you don't ask the right question, that's where it dies, right? Because you just can't walk in there and say, "Hey, y'all want a humidifier?" Because if that ain't the right prescription for them, then they're just going to tell you no, right? And you don't have to be a fancy sales guy. You just need to really be a service technician. Take the meters that you have on your truck. And by the way, Tom Jackson sells tools. So if you need a meter, he can give you one. How's that for a plug, Tom?
That was a good one.
Right? We're buddies. So, but if you don't have a way to read humidity, you probably should have one, right? As a technician. Did you break your spoon, man? Y'all need to get better cutlery around Jackson System. So, but if you don't know what the humidity is, how are you going to sell a humidifier, right? So taking those readings and then getting your service work done and then get in front of that homeowner and say, look, I got your system all cleaned up for the fall. Everything looks great, but it's 20% humidity in here. How's that working for you? And did that sound like a fancy sales pitch? Or did it sound like a really technician-oriented question that I found a problem, right? Because what they're going to do is they're going to tell you, yeah, it's really dry in here and we hate it. What can you do about it? And when you can get to that point, then it doesn't break down right here, right? Because you've proved that there's a problem and you've got a solution on your van, whether you want to put in a evaporative or a steam humidifier. And we do zoning the same way. Like in the summertime, when you go into a house and they've got one condenser sitting out there, but 2 floors of house, what do we know as technicians? Somebody's not liking upstairs, right? So you don't have to go in there and, well, you're not going to ever sell a zoning system by going, hey, you want to buy a $4,500 zone system? Because what are they going to tell you? They're going to say, nope. But if you go in there and take a temperature reading of upstairs and take a temperature reading of downstairs and subtract it, right? And then say, I got your system all cleaned up for the summer. Notice how this sounds kind of the same. But I noticed it's 10 degrees hotter upstairs and downstairs. How's that working for you over here? And then they're going to tell you why they hate it to be hot. And then you can, figure out how you're going to solve that temperature difference between upstairs and downstairs, whether you zone it or do temperature averaging with sensors, right? So whether you're selling equipment, IAQ, or zoning, or anything that you have in your arsenal to sell a homeowner, you just need to be a real human being and ask them a simple, open-ended question that they can't just say yes or no to, right? So try to say yes or no to this. It's 20% humidity in here, very dry. How's that working for you? No. Doesn't make sense because it's an open-ended question. It demands a response from your homeowner. Now, is that being a pushy sales guy or is that being a technician that cares about that homeowner? Exactly. It's a technician that cares about the homeowner, because when you're running your business above board and being, up and up, you care about that homeowner, right? One of the best things I liked about being a technician was when I install, I liked install better than service, by the way. But when you've been there all day long and they've had no air conditioning and you flip that switch for the first time and that cold air starts blowing out of those registers, they love you. You know what I mean? And they hate you when you first get there because I got to pay this $8,000. But at the end of the day, they're going to smile and hand you a check because you did your job correctly and, you know, you care. So that stuff flushes out, and it doesn't have to die here. You just have to be a human and tell them. And then I've got some people that just say, well, how do I know what to do, right? Well, call somebody at Jackson or call me, and we'll help you out, get you into this Air Cycle Pro program. So you set the meter in there, let that thing do the talking for you, and then you're just going over the results with the homeowner, and it's just a no-brainer, okay? So, Air Cycle Pro. So it's a little, you know, I think the machine's about $1,800, and then you got to send it in once a year for recalibration. That's like $1,000. But if you make 20 grand off of it a year, that's paying for it and making your profit go up, right? So, and I've seen people buy $5,000 machines and use them twice, you know. So this is something that you got to put a little skin in the game for. But it's one of those deals that have to be calibrated, and that you're also paying for a yearly cell phone service because you just plug it in the wall and it beams up by a cell phone and gives you the report back, okay?
What's your area that doesn't work?
So if you're like out in the country, and then it will, as soon as you get back into the city, it'll download and you can email that report back to the homeowner. So it's a little funky when you get out in the sticks, but in your normal city service areas, you're fine, okay? But one bar and you might have to wait till you get to town, okay? But they probably don't have cable either. You know what I mean? It's weird. But you know, Indianapolis is a big city, but it doesn't take long to get in the sticks, does it? And you can't even pipe in the sunshine. So here's what we're doing, and we're trying to control temperature, humidity, carbon monoxide, particulates, chemicals, odors, and smells, which are volatile organic compounds, right? And then carbon dioxide is what we breathe out. So like when you have a big training room, like at work, you know, when you have your service training, you got like 50 techs in there, half of them are asleep because you don't have proper ventilation, because when you just have more carbon dioxide at high levels, then, you know, it starts competing with the oxygen, right? So ventilating is a big deal, yes.
If you have a two-story home, do you need to put one on each floor?
What?
The air fiber.
So the question was, do I take the monitor and put it on each floor? So if you want to get a good snapshot of the house, I'd run a report on each floor. Some of my guys over at the big wigs in town here, the Williams Comfort Air guys, they're really smart guys, and they do that a lot. So that really kind of, and they're well trained in this program. So that program teaches you how to do it. So in Q1, we're going to hopefully have that our trainer Jeff Stamp come in and do something with Jackson here for all you guys live and online that want to participate. So let's get into some how we do this, right? So the first thing is you have to have knowledge of this health and humidity chart that Ashrae puts out, because what we're trying to do in a house is control the humidity between 40 and 60%, right? So when we get over 60% in the summer, then that air conditioner has to work harder, because they're made for sensible heat removal, and they do some latent, but it's like an 80-20 split, right? When you start creeping into a 40% latent, that air conditioner, the SEER rating actually goes down, right? So, and they may have oversized that air conditioner, and an oversized air conditioner doesn't pull as much moisture out as a properly sized one. So you have to add a dehumidifier to kind of pull that back down into check, right? And because if you go up over 60, then you got chances of mold taking hold in the structure. New construction is really bad about that, because it rains all May on the inside of that house, and then they dry it in a day, and then they drywall it and everything else. So all that moisture that's caught in that wood has to go somewhere. And then they tighten these houses up very, very tight, right? So in the winter, we start going down that scale. So when your furnace is just cooking the humidity out of your air, you may have to add a humidifier to bring that back up to that. Now you can't have 40% humidity on a 2-degree day without your windows sweating. So we have our controls, like our thermostats with an outdoor sensor, or the humidistat that comes with our humidifiers. They have an outdoor sensor that can give you dew point control that kind of regulates, kind of puts a limit on the output of the humidifier until the conditions outside get better, because your window is colder than, you got 70-degree air hitting the window and it's 2 degrees outside. Where those two temperature differences meet, you're going to have condensation depending on your window efficiency, right? But it's no different than, when you have like a can of Coke in the summertime and you put it outside and it starts beading up with sweat, or your coil where the hot air is meeting the cold air, and or you look at a high-low pressure system on radar and that's where the rain is. Anywhere high and low hit or hot and cold hit, you're going to have condensation. So our controls help keep those windows dry so you don't have that big ring of mold grow around the window or rot out your seals, right?
Can you buy just the sensor?
Huh?
Can you buy just the sensor?
What do you mean by just the sensor?
Outdoor sensor?
You have to have a control that goes with it, but yeah, you can buy the sensor. If we got wireless sensors, or we got some of our Wi-Fi stats use the internet to do it.
Also
The Wi-Fi 8000 uses the internet for the outdoor temperature. You don't have to pull a wire outside. The RedLink stats have a wireless sensor that you put outside. You don't have to pull a wire. But if you use the basic control, you got to pull a wire. Okay.
So the outdoor sensor, the RedLink outdoor sensor is humidity and.
It's humidity and temperature. Okay, they're awesome, and you don't have to worry about, am I putting it on the shady side of the house? You can put it anywhere you want, right? And then if it's the Wi-Fi 8000 and the T10 and our Wi-Fi stats that run humidifiers, they use the internet or hardwire. Okay, and the reason we can't do that with RedLink is because it's a really secure system, and we don't allow stuff to come in through the internet to do, because we use it in commercial and residential, and you got to be real careful on. You need distance and you need security, and RedLink is way better on that stuff. So let's get into the first item up for bid. So this is our UV light, right? Now it's pretty tough, but anyway, we send this thing out 2 ways, right? We send it out with it only needs a 2-inch hole on the plenum, and so we got this little it's like a foam pad with a sticker. So you put that on there and you draw with your magic marker. You draw that out, and then you take it out and you cut those holes out with your snips, and then that mounts on the plenum. Okay, and then you take this. And once you got it on, then it goes over the coil, right? It's got to see the coil, and it snaps in place, and it's a 24-volt light, right? So you mount don't steal the power from the furnace. Put an actual transformer in there. Then I got a ballast and a big long cable that quick connects to that part, okay? It's very nice. And then there's also, this isn't a particular one, but there's a PCO thing that goes on top of this. I got a picture of it. That this thing will keep the coil clean, but it also activates that PCO that takes and breaks down chemicals to non-harmful chemicals. So where I had like a formaldehyde gas cell coming in through here, it'll convert it to water vapor and CO2, which is pretty much your breath, okay? And it'll really knock down VOCs in a big way. You just got to change that bulb once a year, okay? Now, the way we design this thing, the bar is permanent, okay? The light, nope, you don't have to clean it or nothing. But this UV light loses enough intensity after a year that you need to replace it to maintain the intensity to activate that PCL, and I'll get into how that works. But servicing this, you take that out, you take the bulb, you replace it. That's it. So you keep some bulbs on your truck, and once a year you put that in, and it's good to go. And they're not that expensive.
Gas or plastic?
It's glass. Yeah, but it's not the kind of glass that, like, if you put your fingerprint on it, it's going to burn it, like your halogen lights. But you don't want to have, like, you know, like, don't go and off the pipe threading machine and then come over here and change a light, you know. Or if you just want to, you know, put a towel on it, you can. But it comes packaged in some material. You can actually use the packaging to do it if you want. But you don't have to worry about finger oil on the thing. It's also engineered with 2 magnets, right? So I can't see this. Can you turn this over here? So this is metal, right? So that'll actually stick. So if I had like a package unit on a rooftop, or a package unit on a house, or had too many, you know, I got a plenum, but I got like an octopus coming off of it. You could take one of those ducts out of the way, put it on the plenum against the back, right? Stick it inside there, and then because it's got that disconnect, you put the wire outside, disconnect it, move your stuff out of the way, and get to that. So you don't have to like build some field expedient mounting system. So those are pretty cool to have, okay? And it's just a really nice UV light. And it works, right? So that's the main thing. So what is UV? How does it even work, right? So the sun produces 3 types of UV, A, B, and C. So UVA is like these ultraviolet lights, fluorescent that we got here. That's pretty much what UVA is, right? It's just a spectrum of light. You can see it, very low radiation. It's not going to hurt you. But UVB radiation that comes from the sun, you go to the beach and you don't put sunscreen on, and you get that big red burn. That's UVB radiation getting at you. Okay, not good if you get into it for a really long time. But UVC, the reason that we carry refrigerant cards as heating and air people is because of the ozone layer around the earth, right? And there was a big hole in it, and there still is. And you know, chlorofluorocarbons are not the friend of that, so it kind of eats at it, right? So you don't really hear much about the ozone hole like you did 30 years ago, do you? You know, so I'm willing to say it's actually helped by phasing out bad stuff. I mean, if you can keep the environment clean, keep it clean, right? So, but if we didn't have that ozone layer, nothing above ground could live, because UVC radiation takes your DNA and unzips it. So you were this and now you're that, right? So because of that, it really gets in there and penetrates the germ where its DNA is and scrambles it and makes it inert. And inert meaning that it can't infect you. I was a cold, now I'm not, right? Anything that claims that it's doing something more than that, you know, you kind of got to go, really? So, I mean, it's only one way to kill the germs on a coil is with a highly intense UV light. So if you can envision in your mind a one-cell organism, right? And then you got the nucleus and the nucleic acid it's swimming in. And in high school, we would go, where would we ever use this in the real world? And now we're heating and air guys, and all that physical science is where it's slapping us. We got a question?
Got a question from Constantino.
Constantino, my favorite. Constantino's my favorite.
He wants to know, what is the maximum diameter of duct plenum I can use for this UV lamp?
The maximum
Diameter, yeah.
It doesn't really matter. It just got to go in the plenum and see the coil, and it's only using like a 2 to 4 inch space, right? It's got to be in the It's got to be in the airflow going up, and it's got to see the coil. So if you're going in a downflow, you got to be able to get to the coil, right? And then you would actually, instead of mounting it this way on the upflow, on the downflow, you'd actually have to turn it upside down. Actually, that's upside down. And the airflow hits it's got to hit the UV light and push the UV through the honeycomb PCO. Right side up, upside down, depending on your airflow. And it can't see a filter.
That bar, right?
That's only if you have the bar. Well, yeah, but yeah, it's only if you have the air bright bar. But the other thing is UV does not like paper filters. It will eat a hole right through it. So if you don't believe me, just give it a shot, right? And then you'll be going out there and moving it. So it's very, very now it's nothing new about UV, right? So the water department, where you get your city water, they run city water through UV lights to kill the bacteria in the water. And this is just doing the same thing in the airflow and keeping that drain pan clean and keeping those fins clean, right? You put a good 4-inch filter and this UV light over that coil, those coils will be as clean as the day you put that system in. And it's not just doing all this stuff that, you know, I'm not growing bacteria and stuff on my coil. That airflow needs to go through that coil unobstructed, right? Good clean coil, it goes through the fins. If those things get dirty, it's looking for a way through there, right? And when you push the air through something like that, your amp draw goes up, your efficiency goes down, you don't transfer your heat as well. And that's why you want a good, clean system all the time. And then when you got to go back every spring, it's less work you got to do on the maintenance, right? And plus, big, thick 4-inch filters, you change them twice a year, keeps that system nice and clean. You know, the more the fan's running and the air's moving through it, the more particulates you're pulling out of there. And then on this thing, what we want to do is keep the coil clean. And, you know, heat pumps, when you switch them and you get that nasty smell, that dirty sock smell, which is actually what it's called, dirty sock syndrome, that's because bacteria is growing on that coil. With these on there treating that coil, you don't get that dirty sock. So it eliminates that problem. And then the air bright part is actually the air is going to come through here. It's going to zap what's going to be zapped by the surface contaminants, and then the air bright's gonna start rearranging those VOCs. Yeah.
I got a question from Ricardo. He wants to know, is the UVC harmful to humans when in contact?
Do not look at it. It will burn the retinas out of your face. Okay. And there's a big old, that's actually a great question, because these aren't toys, okay? And we got this sticker that comes in there that strictly says don't look at it, right? So that's why we have a disconnect here, and you never want to look at a UV light, because especially one that's a real professional grade product that works, okay? Because I'm going to get a little scientific on you. So the nucleic acid that the DNA mitochondria swim in, and that absorbs UVC radiation at 190 nanometers. Our light produces 254 nanometers, which is well a lethal dose, right? So if it can unzip DNA in a germ cell, imagine what it's going to do to your eye socket. I mean, it'll blind you. So long answer to a great question, but it's absolutely something you don't want to do. Yep.
One more. I think you might have touched on this already. On an upflow system,
Yes.
the A coil, does the light get installed inside the A or
right above it? It shines down on it, okay? And it's just got to see it. So that light's intense enough, and it'll get through, and that's why you want a good clean coil and that good filter keeping the bottom of it clean, so that light can penetrate down through there. And you know how you get up on a clean and check in the summer, and you cut the refrigerant line, or you cut the PVC drain to put your shop vac on it so you can get all that sludge out of there. You never see that sludge. It keeps all that stuff from growing in there. It's so much nicer, and you're breathing all that crap when you have it in there, so it's just cleaner.
You're saying on a downflow, you can put it below the coil?
On the downflow, you still got an A coil, right? And it's usually like that, but you put it to where the light shines up through.
Oh,
okay.
So work that way.
Yeah, you just have
You
to
do it that way. I just can't do it the other way.
exactly. So if you got a downflow, first of all, you got to have Plenum It's either you're in a crawl space, you either go to the crawl space, or hopefully you got a little room to put it on. Sometimes they're around here, they're just slammed on the floor. But yeah, it's got to see the coil. The air hits this first and then goes to the PCO. Okay, so you'll have to turn it right side up or upside down depending on your airflow. Okay, so this is we serve it up two ways. You can put that in first and then go back and add the air bright later, or you can buy it all in one good IAQ bundle. Huh?
What's the bright one they do?
That's the PCO. Okay, and I'll show you. That's what gets rid of the odors. Okay, so to install it, you see there's a picture of the magnet stuck on the inside of a Plenum. If I had no choice but to install it that way. And it just saves some time and very easy maintenance on the light. So if you put it on the return, it's just going to be doing VOC removal. There's no coil in the return, so it really needs to be on that. Huh? So on a heat pump, you still need to see the coil.
Yes, what I'm saying.
But you usually, the problem with the air handler is the filter's usually slammed right there at it. So you'd have to move that filter somewhere else. Otherwise, they're not going to have a coil UV. Okay? So that's the only, it's not, you got to, you know, the job it depends on what you got rolled at you when you get to the job, right? So common sense, don't let it can't see a filter or it'll eat a hole through it, but it has to see the coil. It doesn't take, I mean, it can be like a couple of feet and still eat a hole through it. So I wouldn't chance it, okay?
That's why I was asking.
No, it's good. But I've seen 4-inch filters with, looks like, you know, those Ghostbusters things they fire off. It looks like you fired off one of those through it. It's just a perfect hole. So that's a great 1-2 punch, those two products, right? So this is that monitor I was talking about, the Air Cycle Pro. This is actually an older report. We've kind of jazzed up our reports. But this was an actual house up in Wisconsin. It was a brand new house that was spray foamed. And if you can see the levels here, you're supposed to be at the 500 or below level on the chemicals floating around in your air. This house was spray foamed, and all the new materials, all the VOCs were just stuck in this house. So they had to move out into a hotel. The builder was freaking out, you know, called the contractor calls the Honeywell guys, and I drove up to Wisconsin with my Wisconsin rep, and because they really needed an energy recovery ventilator, because a spray foamed house has to breathe, right? And if you don't think that it matters for a house to breathe, go put a plastic bag around your head for a while and see how that works out for you after so long. You're going to die. I mean, you got to breathe. And all that moisture stays in, all that stuff. So that's what was going on here. They did not want to they said, man, we just spent $500,000 on this house. I really don't have a quick $2,500 to put an ERV in. So we started with the PCO UV light, and we left it in there for like 2 days and then retested. And that's how much of a reduction in VOCs we had in that house. We went from 3,200 micrograms Q. I mean, I don't care about that. All I care about is I went from here to here. Now, the homeowner saw that it still wasn't under the recommended acceptable level for chemicals in the air. So guess what they bought? They bought the ERV too, because the ERV takes the bad air out and replaces it with fresh air all the time. And that got it well below the 500 once we added the ERV too. But imagine off your service truck, I got a problem and I've reduced it. So that's a big, big deal. Now, if you don't change that bulb once a year, it's gonna go back up, okay? So ventilation is way better than this, but that's doing a pretty good job. So we put one in JD's house. JD's our host. And you cook bacon in the morning and you don't smell bacon in the afternoon. That's how that's working. So VOCs are more than just, chemical smells. It's also the food you cook and the lingering odors and stuff like that.
His sock smell goes away every day.
I don't know about that. JD's probably got some pretty rabid feet. But anyway, when you're positioning this to a homeowner, it's really simple. We're gonna reduce the amount of chemicals floating around the air, and I'm gonna keep that coil clean. Okay? Everybody cool? All right. Any questions?
How much of the light, the new bulbs?
So I'm not. Just get with your Jackson guys, and they'll price everything. Because I'm just not sure I know. Go ahead, JD.
Constantine wants to know, do you have air ionizer filter? Does Honeywell make that?
So that's called an electronic air cleaner in my world, and we still make them. Okay.
Is that put out ozone?
No, this is no ozone. So the PCO doesn't. So I think how that PCO works is that titanium dioxide reacting with that intense UV light produces an oxidizing agent that it does not work without the light. Okay, the light is the magic, but actually the titanium dioxide on that honeycomb filter is, but the catalyst is that UV light that activates it, right? And so if you think about, I'm gonna get really deep on you. So the reason that they're trying to find water on the moon right now, which they did find on the backside of it, is because when they want to go to Mars, they're going to take that water and they're going to use a PCO process to separate the hydrogen from the oxygen so you can make rocket fuel. This is just a lower level version of that. I'm just rearranging cells and making it, instead of, this matrix of a chemical, it's that matrix of a chemical now. It's really cool, right? And that's the fun part about heating and air. That's solving a homeowner's problem. Honestly, it's not like snake oil, right? So they work really well. Now we got to filter the house, right? And to me, as a homeowner, I've been in heating and air since '91, right? But it still amazes me how many jobs I go out on with contractors, and the homeowner is still taking the furnace doors off to change a 1-inch filter in it in our market. And I know that this isn't the only market that happens in. And I've been messing with furnaces for a long time, and I still hate taking the doors off. You know what I mean? So imagine an accountant taking the furnace doors off every year, trying to put a 1-inch filter down in there. It's not fun. It never happens. And then they go, wow, this thing ain't, my fan motor's burnt out. Well, you got a folded up army blanket down there where you never change the filter. So putting in a 4-inch filter on every job should be something that you strive to do not only do you make more money on that job, but you should be selling them 2 filters every year, right? Because, everybody gets mad because Home Depot has filters and, you can pretty much go anywhere and buy a filter. But it's really our fault as contractors, because when I was coming up through the 90s, they never changed the filter in the house. We didn't change thermostats till 95, We just leave the old one in there. So we kind of pushed homeowners to those spots. You never thought about that. But think about it. If you put 400 systems in a year and you put an F100, the 4-inch media cabinet, let's see where that 4-inch media cabinet right there or whatever, then you only have to change those filters twice a year. You should leave, when you go in the spring to clean that system for that homeowner, you ought to tell them, I'm bringing you 2 filters too, because we put this 4-inch filter in, you only have to change it twice a year. Or I'm going to do it for you and add it into the service agreement. But if you don't care about it, they're going to go somewhere else and get it. And then you're going to go, well, why ain't you buying it for me? Right? Well, because if you don't take her dancing, somebody else is going to take her dancing.
Or you could be like my uncle and put 4 1-inch filters.
That sounds like a big high static issue to me.
Oh, it was.
So he said his uncle puts 4 1-inch filters together. That's funny. Did you straighten him out?
Like you wouldn't believe.
Okay. So that's a good thing. So what's going on? Why do people want filters? Well, you know, all this stuff floating around in your house, like that's a busy slide, right? But all your attic insulation, all your carpet fibers, you're kicking up dust. You got stuff falling off of you like dead skin. You might have a couple of dogs running through the house. So all the stuff that kicks up particulates, you gotta have something in there that's going to remove them. Now, when you sell equipment, you should really be pushing variable speed, right? Because if the fan ain't running, what's the filter doing? It ain't doing a thing, right? So you got to be careful when you tell a homeowner, hey, buy this fancy filter. They automatically think they're never going to have to dust their house again. You got to set the expectation correctly with your homeowners. You know, we recommend that you buy a variable speed system. So when I put this 4-inch filter in, it's going to run at regular speed until the call for cooling or heat's over. Then it's going to default to a low speed fan, and it's going to always be moving air through that filter, because if you're not moving air through it, it ain't doing nothing, right? So if you want to reduce the particles, you have to be moving air through the filter. And then you have to have a good filter. But pets, all kinds of dust, you know, things that there's people that smoke in their house. There's a bunch of reasons why you might need an electronic versus a paper, right? And when as Resideo, and we go out and we do these focus groups and we try to figure out what homeowners want. The number one thing a homeowner wants is the dust reduced in their house, right? So filters are a big deal, right? So however you can get your company set up to sell them, you should. And so particles, number one risk factor in American homes, because our lungs are filters, right? Now, a couple of you have bottled water in here, right? How much do you pay for bottled water? I mean, let's just assume it's clean, because some people say they're not, but bottled water is generally clean, right? When you go to the gas station, what does it cost you for a bottle of water? $1.50? $2? Well, you do when you're thirsty, right? So, but if you the regular person on the street will go buy a bottle of water at a convenience store and pay $2 for it, $1.50 for it. How much water do you think you drink a day? Like a gallon or something, right? And I'm not talking about in beer, right? But water, you're supposed to drink like at least a gallon of water, 8 glasses of, I don't know what it is. But we breathe way more air in liters than we drink in water. And you would never go to a mud puddle and drink out of it, right? But you're in your house and you got all this crap floating around and you're not doing anything about the filter. That just doesn't make sense to me, right? So, and it doesn't make sense to homeowners either, because that's why they go and they buy all these different air cleaners and all these stuff that they put in each room that may be doing something, but it ain't as effective as a whole house solution that you add to the furnace, right? Or the heat pump. So it's a big deal. And it's easy to know who needs filtration. Everybody needs it, right? So what we're trying to do is capture some really small particles in there that usually go through filters. So those furnace, those fiberglass ones that people use, those things are useless. I mean, they'll get big dust bunnies, but everything else passes through. And you get a lower MERV rating filter, it may do a little better than the 1-inch, but those 4-inch, we start at MERV 11, and MERV 11 gets a lot of stuff. MERV 13 gets even more, right? But as you move up in the MERV rating, you're actually reducing your it gets high static pressure, and you could cause problems. That's why you need to change them.
Now on those, if you went with a bigger size filter,
Yep.
say you only had 16, you went to a 20,
Mm-hmm.
would that help?
So I guess what he's asking is,
But I mean,
if I had a 16 by 25 filter and I go to a 20 by 25, it's okay on paper filters to do that, but you don't ever want to oversize an electronic air cleaner. because if you oversize an electronic air cleaner, you risk producing ozone, an excessive amount of it, because ionizing wires produce ozone as a byproduct, right? So I'll come back to that on electronic, okay? So we're going to get these micron, the higher the MERV, the smaller micron it can trap. So we have two types. We got regular paper, and then we got electronic that captures dust through a pre and post filter, but also puts an electrical signal in there. So it makes a positive, a negative, negative, positive, and it sticks the carbon that's floating through the air. Like if you burn candles, or you got an old coal chute, you got soot in your house, that's going to capture that, right? And we used to, in Nashville, you get in these old houses. I grew up in Nashville, Tennessee. You get in those old part of towns where they've had like 5 generations or 5 different versions of a heating system. I mean, they got coal chutes from the old days. A lot of that stuff's still in the walls, and you could move a picture frame out of the way and you had a ring there. So that's when we usually determine that probably needs some kind of a electronic in here. But most of the time you can just put paper filters in and be just fine, okay? So how that works is on our media filter, we're gonna strain it through the first part of that filter, and then these are not fiberglass, these are microfiber, and they're arranged in such a way that when we impact that dust in there, you notice after about 3 months they're fuzzy looking. That's because it's capturing dust, right? And then we there's some that gets through, right? But it's going to get a lot of it, and especially when you run air, the more air you run through that filter, the more you're going to trap. Electronics move the air through the ionized wire. Makes the negative positive, so they attract and stick to the plates, right? And you got to clean those once a year. A lot of people have moved away from the washable filters because they're kind of a bear to do on a service call. But the homeowner, like I got electronic at my house, I put it in, I got a stainless steel dishwasher. You could put them in a ceramic or stainless steel dishwasher, put it on the 1 hour cycle without the dry, and it'll clean it. But don't put it in a cheap dishwasher with a plastic tub, because all that black stuff will turn that white inside of that gray, because it'll actually, the plastic will actually soak that in. So otherwise, you just run the hottest tub of water you could have, put a little like a drop or two of Dawn in there, and come back when it's cold, and let them dry. You do not use coil cleaner and stuff like that on those electronic cells, because you'll take all the coating off of it that we put on there when we make them. So all you need is really hot water with those cells. And then the pre-filter you vacuum off once a month. The post-filter you change every 6 months. It comes as a pre-charged package. And the post-filter, so when you strip the carbon out of dust, you notice white dust more. So that you're like, hey, this filter is supposed to make it less dusty in here. You're actually just seeing really clean dust. So that post filter traps that white dust more, so you don't have that electronic cleaner effect where you notice it more. It's actually reduced it a lot, but you see stuff you didn't see before that was hidden because it was tinted by the carbon that was in the, it's cool, isn't it? And that's not new technology. It came out in the 60s, just still works. So 1-inch filters, they're not going to get very big stuff. MERV 8, those are those low-cost filters that people will go buy because they're cheap, but they just don't do as good a job. When you pick up a basic F100, it's going to be a MERV 11 filter, and it's going to get a lot of stuff. And if you move up to our MERV 13 filter replacement, it gets even more. And we don't go over 13, except for electronic is, if there's, to have a MERV rating, you have to have an ending pressure drop. Electronic air cleaners never really see a big pressure drop because they're flowing through, and capturing it on the plates. So people love them on geothermals because they don't clog up, right? So that's how that works. We want to be efficient. We want to make sure our pressure drop is regulated, and then we want to make sure we can put that in for a while and hold on to some dust. So paper filters on a normal house, I mean, if you got 15 cats, you're probably going to have to change that filter every quarter. But it's just a regular family of 4, you can move through with a paper filter twice a year on the 4-inch media. Okay, is that cool? So again, when people go to Home Depot and they buy these little fiberglass filters, it's only getting 20% of the particles that passes through there. You move up to a Hrv 11, you get the small to the medium, small to large particles. We're getting 65 to 85% of those, and 85% of the big stuff. You move up to Hrv 13, you're getting 75% of really small group 1 particles, 90% of the other ones. But you got to be careful because the denser the filter, the more you get. You might have to change that one 3 times a year. Okay, and then Lennox makes Hrv 16 paper filters, and you got it. I think their furnaces that they're top of the line measure static, so it tells you when to change them. So there's cool stuff out there from a bunch of different brands. I'm just a big 4-inch filter media fan because, like I was telling you, if I'm a contractor and I put in 400 units this year, and I put 400 F100s in with it, that's potential of 800 filters I can change. And then next year I do another 400. So now I got 1,600 chances of changing a filter. That's big time revenue for your company if you manage it that way, okay? So don't let them go to the box store to do it. They got this program here, Filter Fetch, it's pretty awesome. So however you get your filters, whether it's the old-fashioned way or through their program, get your homeowners on it, because I think the contractor makes money even when they don't touch the filter through your program, right? So that's really, really cool stuff. There's another pitch for you today, Thomas.
I appreciate it, man.
You're welcome, man. You sell a lot of my stuff, so why not? Here's a picture of an electronic filter where we're charging the particles, collecting them on the plate. You just got to keep them clean, okay? F100 is the Hrv 11 cabinet. F200, there's no difference in the cabinet. We just send it out with a Hrv 13 filter already in there. It's kind of silly, isn't it? But the Hrv 13 filters are great. And then you got the F300, which is your traditional electronic air cleaner that can pull a lot of stuff out of there. Look at the water column. This is the static pressure drop out of the gate. 0.23 inches of static. That's not very big, okay? 0.5 is where the limit is. So you got between that and 0.5 after 6 months, you got to pull that out of there. You notice that the water column on this F300 is really low because that electronic doesn't have a lot of, if you keep the post and pre-filters clean, it's got very low pressure drop the whole year, okay? So very, very good. And then we sell a pop-up filter that you can stock on your truck, and you put like 6 of them where 1 paper filter would have went. So that gives your truck, it keeps them from getting crushed like your Freon bottle rolling into it. That's never happened, right? And it gives you more truck space to stock more filters. Okay, got a question, JD?
Yeah, Constantino just wants to know, are you familiar with the ionizer hydroperoxide technology on IAQ? Is that something Honeywell does?
So we don't do, yeah, I mean, there's a couple of different things out there. Look, there's a lot of great IAQ products made by other people other than me, okay? And I get that. What we sell to you is tested and works, and it does the job, right? So there's a couple of different, just like a different thermostat. Ecami makes a good thermostat. We make a good thermostat. There's other flavors, okay? But what I produce is not producing ozone. It's keeping the coil clean, and it's reducing the chemicals in the air. That I don't know how to answer to that general statement, but yeah, there's a bunch of cool technology out there. What you want to not do is produce ozone in the house to replace a smell with a smell, right? Because it's just not good. To ozone around up high is good, down low it's smog. Okay, so you just kind of want to avoid it. And some people are really sensitive to it. The homeowner will tell you, "What's that smell? Oh my God, take it out of here!" Right? So you just got to be careful on some things. Just do your research, Constantino. But you'll be happy with our product if you give it a shot. Okay. So the pop-up pops up, and it slides right in the case. We also make a pop-up 2200 and 2200 for space guards. So space guards are nice filters, but you got to buy an upgrade kit, or you got to pull the big white box out and do combs and filters. This has the two rails are kind of offset. Once you pop that filter up, those two rail offsets slides right in there. So it is the best thing to have. So you can have the traditional Honeywell sizes and the two space guard sizes, okay? So thanks for the pitch, and this guy up front loves it. So now on now we've got a bunch of individual returns in Indiana here, but I grew up in Nashville, Tennessee, and it is like the world's bastion of central returns, where you actually got a filter grill, because there's a ton of package units down there, and you bring this one big pipe up through the crawl space to a big wall stack that's got a filter grill where you take a 1-inch out and put it in. If you've got like 6 inches behind that where you have the wall stack and a box, then this has a 1-inch lip but a 4-inch deep filter, and you can stick it in that filter grill and get a 4-inch media performance out of a 1-inch spot. Yep. And you can do that. So in commercial, where you got these sealant returns, you can actually put them in the sealant returns and take those filters out of the deal up, the 2-inch filters up there, or just in a residential deal where you got a big 20 by 30 or 24. Yeah, they got them. Sell a bunch of them here, by the way. So very, very cool thing, and a lot of people didn't know we had it out. They've been out for 20 years. We've had them for 20 years.
Need better marketing.
That's what I got you for, Thomas.
Oh, all right. We need to do better.
No, we sell a bunch of them. A lot of people know, but I mean, you didn't. You've been eating there a long time, and he didn't know about it. So that's why we do these, right? All right. So we're going to move into humidifiers, which is I sell a lot of humidifiers, right? I'm in the Indianapolis, so we sell a bunch of humidifiers here. You go to Chicago, I think there's more humidifiers sold in Chicago than just about anywhere. I mean, it's just you got to have it when you get into a lot of heat. I mean, when you got fossil fuel heat. I didn't realize this till I was in the Chicago market for like 6 years. Radiant heat really dries a house out, So you might have a boiler system for your heat, but an air handler for your cooling, and you can add that steam to that air handler and let the fan in there distribute out the steam, and I don't need the heat from the furnace because there's no furnace, right? And it generates its own heat, and it distributes that humidified air for those radiant systems. And then on heat pumps and furnaces, it's a great source of humidity. And then on high temperature plenums, you can use evaporatives, right? And we got a couple of different flavors. We got, pad, you can drop water through the pad, and that's the evaporative, or we generate our own steam with electrodes down in the tank. So a couple of reasons why I'm going to need a humidifier in the first place, right? When I go down remember that chart, when I get into the 20% range, really start all the moisture that's in your house, including you, right? Because we're 70% water as humans. once that house, it starts pulling, that low humidity starts pulling the water from you and from your structure, right? So once it starts evaporating it out, your cuticles start receding. You get ashy knees. You know, your floorboard starts separating. You lose your nasal. You know, kind of like your defenses and your, which is kind of your boogers. You know, your snot. That keeps you from getting sick, right? But when you lose all that, you're susceptible to getting sick. So there's a lot of reasons why you want to humidify. But when you have your humidity correct in the winter, you can keep your temperature a little lower, right? Same in the summertime. When I can keep my humidity lower in my house, I can set my temperature higher, because it ain't the heat, it's the what? It's what humidity holds heat. Same in the summer, same in the winter. So I want to add it in the winter so I can keep from like running my system more than I should and be comfortable. And you don't get the bloody nose and all the other stuff. So the big thing is that if you've got a ventilator or you got an open fireplace, you got to kind of shut that stuff. Well, you don't shut the ventilator off, but you got to compensate for having that ventilation. So an HRV is different than an ERV, right? An HRV dries the house out. An ERV kind of keeps the moisture out in the summer and in the winter. So you got to be careful about infiltration, because that'll kill your humidity. I had a guy in Chicago that lived on the lake shore. He had steam radiator heat and air handlers and it was, the steam boiler was not regulated. So you know how they regulate the temperature in a steam boiler house? They open the window right on Lake Michigan, 2 degrees outside. The guy's calling me going, I can't keep my humidity. I'm like, I go there and the windows are all cracked all the way around the building. I'm like, you got to shut the windows. He goes, it'll be 90 degrees in here if I don't. I said, well, you need to talk to the building manager about some control on this 100-year-old steam boiler, which they're not going to do, right? So you got to be careful where you promise stuff, because there might be a condition that kind of negates it, right? Is that the right word? So I've never actually used that word in a sentence before. Now, what you got to be careful with, that's the word of the day, is negate, right? So plenum pressure is very important for a lot of different reasons, right? So how many of you knew that if I put a bypass humidifier on the plenum, that if I'm over 0.3 static, it overpowers that humidifier and will throw the water in the floor? Did you know? Anybody online, JD?
No answers.
I mean, I'm telling you, if you got, now what causes high static plenum pressure? Well, let's say you go there because the homeowner's complaining that it's not heating properly, something's wrong, and you go there and Rip and Tear Heating and Air changed out the furnace 2 years ago and put a 120,000 5-ton drive furnace on a 3-ton duct system. Anybody ever seen that? It's not very uncommon, I'm afraid to say. Well, that could cause a static pressure problem. Or I've got the properly sized system, but as an installer, either I didn't do it or I wasn't trained to do it. I mean, you'd be surprised how many people take a piece of equipment out of a box, stick it in the basement, hook ductwork, electrical, and gas pipe to it, and leave. And they never set the delta, nothing. They never set it up. And that could make you have a high-speed fan or high static because you didn't set it up correctly, right? So this is the Honeywell part of our install guide that tells you your static limits, and this is out of the Aprilaire humidifier guide. If I've got a bypass, I can't have static pressure greater than 0.3 static. If I got a powered, I can't have more than 0.4 static. This is out of Aprilaire's install manual for their powered. They've got the same exact limit that I got. And it actually warns you in theirs that if you got a zone system, you better have a bypass, because if I got people that don't put bypasses in all the time, whether it's Tom's zone panel or mine, right, Tom? And we have ways to fix that. But it manages the static, doesn't it? So whether you use my bypass or Tom's ESP system, I don't care how you manage the static. You just got to manage the static, right? So if you go up on a job and you want to sell a humidifier and they've got 2 zones and no bypass, go shut a zone down and put your Magna-Helic on the Plenum. It's going to be off the charts, right? So you've got to put a bypass in. Honeywell, we make a bypass that has it's not a weight. It's actually got a static pressure box on there, and it's very nice. And Tom sells them. You can actually roll that pressure down to below 0.3 or below 0.4, and it'll never overpower that humidifier, right? And then if it's on a non-zone system, you got to make sure you adjust your fan speed properly to make sure that your limits are gonna not exceed what we put in there. If you know anything about if you learned anything about humidifiers tonight, that one is something you got to make sure you'll be a better service tech knowing that, okay? The other thing that's a big mystery is sizing them, right? So if I'm laying carpet, square foot's fine. Length and width of the room, and I cut the carpet to fit it. Humidifiers are not doing just the length and the width of the room. It's doing the cubic feet, which is length times width times the ceiling height, right? So I ask this question when I do local trainings with techs, and I say, if you had a 3-story house and it had 2 floors that was finished, 1 floor that was unfinished, like, unfinished basements, but it's still blowing heat and air, they still got a couple of vents cut in to maintain the temperature down there, you have to add that into the mix. If you just add the top 2 floors, you're going to undersize a humidifier, okay? So you would take, let's say you got the top floor is 1,000 square feet, the main floor is 1,000, and the basement's 1,000. That's 3,000 square feet, and then you measure all 3 ceiling heights, and you get an average. And let's say the average is 10 foot. So you'd set up your math problem, 3,000 square feet times 10 foot ceiling height. You only have to do the average, not all 3 floors added together. And then equals what? So 3,000 times 10 is 30,000, right? This chart, and we can send you this chart. All you got to do is email on the web thing there, and they'll send you this presentation. This chart is made by ARI. ARI is kind of the governing body of heating and air, right? That's how we build our furnaces and all of our stuff to their specs. So I didn't come up with this chart. This is ARI Guideline F, okay? And what I have to do is, it's going to give you on this top line here, it's going to give you the cubic feet of the house. Then it's going to ask you, is it tight, average, or loose? And if you're a technician, you've been in enough houses that you can kind of visually know that, hey, this is a tight house, or this is kind of average, or it's a pole barn, okay? And then if it's a tight house, 30,000 square feet, or excuse me, cubic feet, I only need 13 gallons a day to meet my 35% Ashrae recommended, okay? If I have that same house in an average, I need 26 gallons a day. If it's a loose house, same, layout, 40 gallons a day. So you can see how you could put in, especially a steam humidifier that only produces a finite amount. Like this one, if I put 220 to it, will give me 22 gallons a day. But if I put it in a house that needs 40 gallons a day, they're going to feel like you ripped them off, right? So we need to make sure we put the right system in based on the house. So steam humidifiers, average and tight houses is where they're going to lay. You never want to put a steam in a loose house unless you put enough in to overcome the ARI recommended size, okay? As you move through the system, evaporatives have this pad, right? So this pad has to have the furnace heat going through it. The water drips down the pad, and the heat pulls the moisture out of it and delivers it into the home. Okay? When we tell you that this humidifier is an 18-gallon a day humidifier that's got a pad in it, that means in our lab, and Aprilaire in general all have to manufacture these with the same lab results. We run 120-degree plenum air through that for 24 hours, and that gives you 18 gallons of output. So as your furnace runs less, your demand ain't as much, but you're not getting 18 gallons out of that thing. It's only as your furnace runs more that you creep up closer to the limit. Does that make sense? Okay, question.
Yeah, Ferris wants to know, in commercial rooftop units, like around 7.5 tons or up, can you install more than one humidifier to get more gallons per day?
So in commercial, what we're selling here are residential humidifiers. If you're going to do something in a 7.5 ton, you probably need to get somebody that's going to make sure that if it's a new construction, usually the mechanical engineer can tell you how many gallons a day you need to put in there. If it's going to exceed the 22 gallons a day that mine puts out, or I think Aprilaire puts out like 34. General has a higher output one, but you just got to make sure that you put in the right amount of gallons per day. So I've seen people put 2 steams on one system, and if you've got the airflow, you're fine, but you'd have to twin them, and you'd have to relay that out somehow. But they make commercial humidifiers. We don't, but they make like big, large commercial. So the person the company that we partnered with to make ours is called Nortec. They invented electrode humidifying. They make super big industrial type commercial humidifiers. So use mine where you can, but you have to make sure that you've done a proper load sizing to know how many gallons a day you need in there. And if you can fit it, make it work with mine, fine. But an evaporative ain't gonna do nothing for you.
What if you oversize it just a little bit?
There's no such thing as an oversized humidifier because your humidistat will stop it. Actually, I gotta run 110. This will run off 110 or 220, but it's 11 amps. So I have to pull a wire no matter what. So if I gotta pull a wire, why wouldn't I pull it a 220 and let it rock 22 gallons? That's what we did at JD's house. JD didn't need 22 gallons, but
He's got 600 amp service in his house.
200, and it was full. I actually had to go, and I had to pull the, I had to put piggyback breakers in there to pull a circuit, and you should have seen my big frame in the smallest part of his attic. We had to go outside the house, run a wire. I'm like a mouse. I get flat.
I was thinking that movie. I can't remember her name. The house.
Well, I'm severely claustrophobic, so I was really sweating in one end of that house. But anyway, you got to put a steam in. You got to make sure that it's the right house, right? And then you got to make sure you got a way to pull a dedicated circuit, and then it's only a 15 amp circuit you need. And pull number 14 wire because that'll fit in my lugs really nice. Okay, if you're gonna pull 20 amp, a number 12, put a disconnect and reduce it to 14 so it'll fit in the lugs. Okay, but very, very simple. So I'm either gonna use evaporative or steam. So like I said, when we use evaporative, we steal the heat from the system to produce moisture. Steam produces its own. Has its own heat source, okay? So then we look at what we have for you. So we make water wasters, right? That means it's a humidifier and they're low cost and they work, but they're gonna run 4 gallons down the drain to get 1 gallon in the house, just like everybody else's. But then we have these advanced ones. So this one is an advanced one, right? It's got a board in there that gives you a nice, easy set of terminals to wire it. It's also got a relay in there that breaks the green wire between your furnace and your thermostat, so you can force the fan on with a call for humidity. So if I got a 120-degree furnace, I could pretty much let this run when the heat's running and it's going to be fine. But if I got a heat pump, something that's only giving me like a 105-degree plenum, I need to break the green wire or put a thermostat on that forces the fan on with a call for humidity. So even when no heat's running, it's dragging 70-degree air through it and actually still humidifying, just at a lower level. So if you got a downflow that's slammed, my coworker has a Bryant downflow that's slammed, and the only thing we could put in there was a powered on the return, right? Return's always 70 degrees. We couldn't get it to work right until we forced the fan on with a call for humidity, and it's always running 70-degree air through there, and he's hitting a 40-degree set point in that house. So the key is longer run time or hotter furnace. Now, I'm sorry, what was your name? Nate. So Nate here, who you with, Nate? Comfort Professionals in Indianapolis? Columbus, Indiana. You drove an hour up here for this? I love you, man. So we were, oh no. So Nate and I were talking, oh no. I'm not sure what I did. Technical difficulties. So, well, let me finish, Nate. So can is he coming over here to put that back up? So Nate and I were talking about what were we talking about? No, I lost my train. JD made me lose my train of thought. We were talking about furnace run time on evaporatives. Oh, yeah. On you know, because you put stuff on the return. So you just need to run that, force the fan on with a call for humidity. So
Humidifier on a return rather than a supply.
yeah, now I don't remember what we talked about. Some people hook cold water to these, and some people hook hot water to these. It's really contractor preference, right? You're not going to get an extra 20% humidity out of the humidifier by adding hot water to it. It will speed up the humidifying process, but the other thing it does is that the calcium magnesium that's in the water that makes it so when the water evaporates it's white, right? That stuff just corrodes this humidifier faster than cold water does. So what makes an evaporative work is the heat going through the pad, not the temperature of the water dripping through it, right? It helps a little, but is it worth having to clean that more? So I don't care what you do, just be aware that's why ones you put hot water in are a lot dirtier after a season than ones that you run cold water through. Okay, question?
Yes, I got a couple here real quick. Andre wants to know, when should I be concerned about biological growth in the ductwork with a humidifier?
So it's always a concern to have biological growth, right? But the humidifier needs to work when the fan's running, okay? So if you don't have the fan running when the humidifier is working, you're going to have a biology project in there, okay? But under normal conditions, it's not going to mold up a system, okay? And then if you put a UV light in, and then that's going to help out too. And then people go, well, if I got the UV light, you know, right here, and I got this on the side of it, is it going to eat all that up? All this stuff's UV resistant, okay? So we put carbon black, which is the material that keeps UV from making that brittle. And then this thing here, our pad that comes in our advanced models, you ever seen a big cooling tower, like on a commercial job, and there's water coming down there? Well, those things can get moldy, okay? So what they put on those water tower panels is called an Aegeon coating, okay? So if you take Ag, that's a periodic symbol for silver. There's actually a little bit of silver in the dip that we dip that pad in, and silver is natural antimicrobial, so it's kind of an inhibitor from letting mold take hold on that pad during a heating season. So when you change out pads, you want to use the Aegeon pad, not the plain Jane pad. So good question, but every time I've ever seen one mold up, it's because they didn't have the fan, they wired it wrong, and the fan wasn't cutting on with the humidifier.
And then,
Definitely happens.
Constantino also wants to know what will be the new supply temperature after humidification. Like
So if it goes in
temp is it?
120, it takes a little bit of the heat out, but it's not that much. And you're only using like a 6-inch pipe worth of like 100 CFM of airflow going through the thing anyway.
Well, your supply temperature probably go up anyway, because now you're putting hot air in the return. Right?
So when you buy, his question was, you're putting hot air in the return. You got to be careful about that on bypasses, right? And there's some furnaces that don't even want you to put a bypass in, because the fan motors are really susceptible to higher return temps. So a powered is really great because it steals from the supply and blows back out into the supply. So you got to kind of know your equipment, but
Look to bring from the space.
Huh?
Space.
well, you got to have space too, right? So there's a lot of factors of what to use, but I think Constantine, it's not going to make your furnace not heat, right? It's just using the heat to help humidify through a pad, right? Because I have to have the furnace heat to make that work, or the plenum temperature blowing through. And then the lower the plenum temperature, the less output that's going to give you, but the longer run time you can make up for it. So hopefully I answered that correctly, Constantino. All right, so this is kind of giving an illustration to how that's working. Dry air goes through wet, comes out humid, okay? We got different ways to do the pad, like I was telling you. We also have a motorized damper on there that opens with a call for humidity and closes after the call's over. So you don't have that damper staying open all summer long, or even after the call for heat, it closes it. So
What model is that?
the advanced model bypass. Okay. It also cuts the water a third, the waste. Now our powered, if you notice, traditional powereds have a big propeller fan in there, right? Excuse me. We went to a squirrel cage because we can make it quiet. A variable speed furnace is 55 decibel. Our old propeller type humidifier was 70 decibels. Our new powered's 48. So it's quieter than the furnace, cuts the water use in half. And when you change the pad, you pull out the pad like a media filter, and you just pull it out, change it. You don't have to like take half the humidifier apart and do all that junk, right? Multiple mounting angles. So when I take this thing out of the box, I don't have to strip it down to rebuild it on the plenum. It's got these 2 feet that actually hang into the hole, and then you push that on there, and then you can zip screw 2 zip screws in, so it's ready to install right out of the box.
What on duct board?
Come on, man. What about on duct board? You gotta make it. You can't hang stuff. You know what to do with duct board, right? Which I absolutely hate, right? But sometimes if you're going from supply to return or return to supply, this is facing the wrong way. So on our basic model and others out in the marketplace, you got to completely take this thing apart, turn it upside down, and rebuild it, right? Well, on these, you take the Molex plug out because it's got that damper, and you actually just flip it around. So it takes like 2 seconds to mount that in there, okay? Well, when you're a trained technician, it only takes you 2 seconds. And then it's got another plug on the other side for the electronics. So that's converting that right there on the spot, and it just saves a lot of time, okay?
That helps so much with that motor drive damper cooling.
Yeah, well, I mean, it just stays open all summer, and that's 100 CFM that should be in your house, not recirculating through your system, okay? So we got basic, we got advanced, and we got our powered, okay? So we got something for everybody. And then our steam is pretty awesome. Now, True Steam was horrible, okay? I get it. But we moved away from that, right? So we partnered with Nortec to make an electrode, okay? Now, this electrode is very simple, but we engineered it to our specs, and Nortec builds it for us, okay? So we wanted to have, the only really good thing about True Steam is that you can mount it directly on the plenum. This one you can mount directly on the plenum. So it comes out of the box with the remote mount nozzle, but you can swap that out with another nozzle we put in the box that actually you cut a 2-inch hole. That's a remote mount nozzle. So if I'm going to remote mount, the other nozzle that's in the box that's for the direct mount becomes the nozzle I place on the duct to mount my 5-foot hose that comes with it. So it's direct mount, or it's got a 5-foot hose in the box to mount on the wall and pipe it in. We also sell a 15-foot hose. So if you want to put this in like if you got ductwork in the attic and you want to mount this in the conditioned space and go up through the attic into the ductwork, you can do that. Or if you got a downflow where you need to make a turn and put a T and a P-trap in and inject it that way, that's what that extra hose is for. Or you might be more than 5 foot away from directly injecting it into your furnace. No, you can go up to 15 feet, but you can't take the 5-foot hose and add a 15-foot to it. 15 is the limit, okay? So, and then when you clean this thing, you take the tank out once a year and you slap a new one in, okay? Way easier than the old way of doing things, okay? And
Do they recommend putting that filter on it still?
What filter?
Pre-filter?
No, so how these things work, the dirtier the water, the more efficient it is.
Oh, so you don't have to have salt?
No. So we had to have RO water in the True Steam because it just didn't. Honestly, you put hard water in there and it'd evaporate the water and you had all the hardness left in the tank, and it just ruined the thing. This is taking the electrode, is sending the electrical signal through that element in there and actually evaporating the water by creating heat through the electricity. And the electricity is conducted by the hardness of the water. So if I had RO water in, or reverse osmosis water in there, there's nothing in it. It would take a month to start steaming. So you want to make sure that when you put your water line in, you're not doing RO at all. Actually, you want to pipe it in from the dirty water coming from the street. Softener, if you're on the softener side, it ain't going to hurt it, okay? And we pre-salt the tank, so when you've started up, it boils water in 15 minutes. You're able to check it out and leave, okay? So very, very cool piece of gear. And if for maintenance, you want to make sure on our humidifiers that you shut the water line off, take this out. There's a screen in there you need to clean out. And there's a screen in there you need to clean out once a year, okay? And you're good to go, man. So, but it's like anything else. If you don't maintenance the thing, you're going to have problems. And that doesn't matter. Doesn't matter what brand it is, right? So keep them clean, size them correctly. If you're going to put steam in, I just put 220 to the thing because you got to pull a wire anyway, and you can't oversize them, right? So if I only needed 13 gallons a day, but I've got 22 gallons a day, it just humidifies quicker, and the shorter run time with an electrode, the less amps you're drawing and the less money you're paying to humidify your house.
Does it matter if it's a supply return?
It's got to be on the supply. Got to be on the supply because I'm injecting steam into a system. If I'm putting steam in, then I get.
How close can it be to UV light?
It can be right on it because we've got. I mean, you don't want to like put the steam under and blow up on your light. You want to be above it, okay? And then your plenum, you don't want to put, you want to put it a good 2-3 inches below the top of that plenum, because you know, if you put them up too close to the top, it'll condensate on the top of that plenum. Okay, so you want to make sure that you're down from the top enough to where the air can blow through, and you don't want to be under 250 CFM. Okay, so you know, we're usually at 400, 600 CFM anyway, right? So you're good to go. So when you're in low speed fan, this is still distributing the heat or the humidity without over condensating in there, okay?
So this is the one they switched to from the True Steam.
Yes, yeah, and this has been out for a good 2 years now and been a very, very good machine for me, okay? Got a question?
Yeah, we'll try to work through this question together. Fairs want to know, he's asking about the humidistat indoor setting. I'm going to try to paraphrase this here. The setting on the humidistat percentage depends on the outside temperature. Why is that? For example, if outside temperature 20 degrees setting will be on the humidistat will be 35%.
So if what he's talking about, what he asks is, why do we have like a setting for, you know, I want to have 35% or 40%. Then we have another setting called frost protection, okay? And that's on a 1 to 10 scale. So like I was saying earlier, if I take this soda can in the middle of summer and I set it out, I took it out of my fridge and I set it outside, what starts happening to the bottom of that can in just a few minutes? It starts beating up with sweat, right? That's because I got a temperature difference. When I got a window and it's 20 degrees outside and 70 in my house, I've got a temperature difference at the window. At a certain humidity level in the house, it starts beating up sweat at that window, okay? So I want to put in a dew point control to as my temperature drops outside, thanks man, it actually limits my output of my humidifier. And then as the conditions improve, it lets it humidify more, right? That's the only way to keep a window dry. So you either can manually do that, which stinks because you'd have to, every time the temperature changed, you'd have to run downstairs and go up or down. If you set it at 35% and then set your window setting between 10 and 1 that keeps your windows dry, it's automatic. You never have to set it again, right? So you either manually do it or you set up the automatic. Automatic is way better, right?
How do you know what between 1 and 10?
So there's a chart in there that shows you, but the best way to do it is set it on 10, and then the first week of cold weather, tell the homeowner once the sweat starts beating up, you move it down 1 point a day until you don't see the water, and then you've got the sweet spot. So you got 10 algorithms, or you could, like our Prestige or our Wi-Fi stat that runs a humidifier, it starts at 5 and lets you adjust from there, okay? And it'll tell you that when you set it, it'll say, it'll tell you how much it'll limit and how much it'll, but what you're trying to do is keep the windows from sweating, okay? And you have to limit your output of your humidifier based on the outdoor temperature to make that automatic. So if you want to get my phone number or email from JD, whoever asked that question, I can email you the algorithm chart if you need an email copy of it. But it's in our HumidiPro book and it actually shows you all 10 points. So it's just a limit switch, okay? It's just like your limit in your furnace. Was it go out off on 160 degrees or something? Your limit switch? So it's just a limit switch for the humidifier to keep the windows from getting wet. That's all it really is. All right. So steam humidifiers work really well. You just got to make sure you're sizing them correctly and change that cylinder once a season. Sometimes it'll last more than a season, but they're not that expensive. So I'd put a new one in every time I went out and cleaned it in the fall, okay? Which, JD, you're gonna have to do yours, okay? There's the direct injection, and there's the mounted on the wall with the 5-foot hose, okay? So it gives you a couple of options.
What was that drain stuff?
It's just drain. You gotta have an air gap on your drain, okay? But it's
Is that a trap in it, that circle?
no. So that drain, that's an old picture on our 700. Yeah, we don't have that here. I don't even know why that's in there. So we drain through the tube down through the machine now, okay? Yep, sorry, man. And then we pack it. So this was, what was that guy's name that asked that question on the dew point, JD?
The what?
Who asked the question about the dew point?
Bears.
So there on here, it'll show you the humidity setting, and then that's your window temp setting, okay? When you go in, when you got that built up, once you add that outdoor sensor to that, then it'll automatically bring up that window setting for you, okay? And then these thermostats that will run a humidifier, once you add the outdoor sensor or use the internet, depending on if it's Wi-Fi or RedLink, it'll do that for you, okay? Right? So now wiring, I've got a whole set of wiring diagrams that I've made up for all the Honeywell stuff, the thermostats, Carrier, Infinity, and Bryan Evolution, and a couple of other brands where you have to put a peanut relay in there. So this is an example of the diagram I kind of hand did, because I like easy. I don't like to have to go out to a job and think too much. So it tells you where to plug it into my thermostat and where to set the dip switches on the board to operate. So if you need a copy of those cheat sheet wiring diagrams, ask Jackson and then we'll send you a copy, okay? All right, dehumidifiers, not going to spend too much time on dehum, but we make 3 different size dehumidifiers. That's a pretty bad dehum job. But we want to keep dust mites from growing. We want to keep the house from getting too humid in the summer, because just like a dry house pulls those boards apart, wood floors in a humid house will cup. You ever seen cupped floors from too much humidity? So it's really bad. It also really is not that comfortable to have a cold house with high humidity. It feels like you live in a cave, right? So we want to get that out of there. Now we have 65 pint, 95 pint, and 120 pint dehumidifiers. They also have a ventilation port on there. So you could bring fresh air in, dehumidify it before it dumps it in your house. Keep your house into a positive pressure so it's keeping the moisture pushed out of the envelope and it's dehumidifying at the same time. So very, very nice systems. Now, a dehumidifier is pretty much a heater and an air conditioner together, right? And like in commercial, you know how, excuse me, man, I'm a little dry in here. Between the, on a commercial job, you can actually run heat and cool at the same time to pull moisture out. So I'm doing the same thing with a dehumidifier. But we pull very low amps on those things. So even the 120 pint only pulls 5 amp of power. So you can plug it into any plug that you got, okay?
So you don't wire that doesn't pipe into the heating air system?
That goes, so there's a couple different ways that you can put it in, okay? 65 pints a day, 90 pints a day, 120 pints a day. We also e-coat the coil with epoxy coating so they don't have that rotting effect, okay? And then here's an example of some different ways to install it. Those cabinets are insulated, so you can put them in an attic, but they produce water, right? So there's actually a drain pan float switch connection that you can put a float switch in and take the jumper out, put the float in, and it'll shut it off if it fills up that drain pan. But anything you put in an attic that produces water has to have a pan, okay? If you just lay it up there and it leaks, it's on you, okay? But you want to go out of the return, back into the return. Some people go out of the return into the supply. I'm not a big fan of that, but if you do, you have to put a backdraft damper in there, right? So the best way to do it is out of the return, back into the return, or some people in a basement system put a filter, like a grill in the basement and dump it back into the return. And that really knocks that basement humidity down, okay?
That's what I got now.
So out of if you got to put a backdrafter in if you go return to supply. This is a separate return going in the supply, but you got to put a backdraft damper in there. My favorite is out of the return, back into the return, and it just works a lot better. We've got. I'm sorry. Go ahead.
What operates
What operates what?
these machines?
What turns the dehumidifier on and off? So you need a dehumidistat, or our thermostats have the ability to do that too. Okay. The 65 pint has an onboard dehumidistat, but the best way to do it is in the space. So RedLink stats and our T10 stat that's got a wireless sensor with it, they read humidity. Those wireless indoor sensors read humidity and temperature. So you could put your stat on the main floor, run a wire down to your dehumidifier, mount the wireless sensor in the basement, tell the thermostat to sense from the humidity from the basement, but control it from the stat upstairs. So it's really cool. You're going to have self-leveling feet. You're going to have a drain tube. Drain tube has to have a P-trap, okay? Because it's a negative pressure, just like an upflow down, not upflow coil, but an air handler has to have a P-trap in it, right? So anywhere you got a negative side, you don't want to bring smells in through the drain, okay? So it's going to have a P-trap. Self-leveling feet, and then you've got a float switch jumper. You got a GTGF so you can break the fan through and cut the fan on with a call for humidity, just like we have on our advanced humidifiers. And then this is the built-in dial on the 65 pint, right? So you can actually set it as a standalone, turn it on and just set it in the basement and drain it.
Now, does it have a 5-year warranty on commercial applications?
Everything's 5-year warranty, okay? So 5-year warranty on all our stuff, right? It's got a filter in there you got to change once a year, okay? And that's about it. So
How hard is the filter to change?
the what?
How hard is it to change the filter?
So it's a magnet door.
Okay.
You pull it off and you slip it right in. It's a 1-inch filter, but it's a specific size. So you got to buy mine, okay? Which kind of stinks, but you know, I'm feeding kids, right? We didn't design it that's just how it ended up. I don't know why.
So it's just a regular medium?
No, it's a size that you'll never get.
No, but I mean
It's just like a 1-inch pleated filter is all it is.
But I mean it's just
Change it once a year, okay? So I'm gonna finish with ventilation, okay? Now, like I said, ventilation is a big deal. When these houses are super tight, all the crap that they built the house out of stays in the house, right? So before we had these fancy machines, I'm like Bill Nye the Science Guy today. So when I was an in-home salesman after I was an installer, went to service, and then went in the sales side of the business. And I had a hard time 20 years ago when I did that, talking to homeowners about ERVs, because I sold them, right? So I figured out that words tell, pictures sell, right? So I would when I wanted to sell to a homeowner ventilation, like taking bad air and replacing it with good, I would take a glass and go to their sink, and I would say, this is the dirty air in the house, right? Then I'd turn the cold tap water on, and I'd let it run through. And now this is the ERV bringing fresh air into the house. And after it runs, you know, for a while, guess what's left over? It's pushing the bad air out, and then you end up with clean air in the house. That's a pretty decent visual, isn't it? That's how these ventilators work, okay? Now, when you're doing a just a fresh air intake, then all you're doing is bringing outside air in, and that doesn't really help on a spray foamed house. But on a average built house, it's great because you know where your combustion air is coming from, and you can keep the house into a positive pressure to keep the negative effect from happening, right? And if you ever been in a house where you built a fire and the negative pressure is so great that the smoke rolls out of the chimney, and then you crack a window for it to pop back into shape? That's called exhaust ventilation. So that top house, I got all kinds of stuff pulling the air out, but I don't have any makeup air, which is nothing new in commercial. You got to do makeup air in commercial, especially if you got a kitchen hood, right? But in a house, if I got a bunch of stuff bringing it out, it's going to pull it into a negative, and then I open the window and it pops back into shape, right? So if I've got exhaust ventilation, which is most houses, I need to add a ventilator or a 6-inch pipe that works with the furnace to keep the house pushed out, or an ERV to keep a balanced net zero on the envelope so I'm not pulling to my depressurization limit that's going to reverse my chimneys. What else is a chimney? Your water heater. So if I've got -5 Pascal, which is about the weight of 5 sheets of notebook paper, negative, it's going to reverse my chimneys, and now it's called spillage into your indoor environment, and that's just carbon monoxide coming into your house, right? So ventilation's a big deal. Now, how do I size them? Well, this is the Ashrae chart for sizing a ventilator. It's just kind of a cheat sheet. You go by the square footage, and then up here's the number of bedrooms. And then when you add those two values together, Ashrae's already done the math. So that in a house that's 3,000 square feet with 3 bedrooms, I need 120 CFM of continuous ventilation to keep it clean like I showed you with that cup of water, okay? So that's how you size them. And we make 150 and 200 CFM machines. And you got to be careful. If I put a 200 in and I got 9 million 90s and a wall cap, every 90's, 5 foot of pipe, and then a wall cap's like 15 foot of pipe. So, and then I got my linear feet. So you got to kind of use your SMACNA guideline, right? But then you have to have a differential on your MagnaHelic where you got the high and the low. You put a differential pitot tube in there, and you convert in the manual, there's a static pressure to CFM conversion chart. And then we have 2 variable speed fans on that ERV, so you can balance them correctly. Okay, it's freaking awesome. Can I say that? It's awesome. So I can put a 6-inch damper in, or I can put a 6-inch damper to regulate the air coming through there and dehumidify it, or I can put an ERV or HRV in. So very, very cool systems here. So by far, I sell a bunch of these, okay, in new construction. 6-inch damper with a control. You don't really have to buy that control anymore because my thermostats, like my Prestige or my Wi-Fi 8000 or the T10, you can just tie the damper into the thermostat and put the number. It's got the number of bedrooms, the square feet, and the CFM. So you're actually, yeah. So
Where's that?
it's actually on this control. It's also in my thermostat. It'll ask you the square foot, number of bedrooms, and the CFM you need. So that chart, you just match it up to that and it'll run it for you.
When you tell it it's got.
You tell it what it's got, right. So it's very simple. And then the dehumidifier, you run the fresh air in and it'll dehumidify it as it's bringing it in. So you can keep this stuff from happening when you got a proper 6-inch vent. Now, we make these little bath fan, so you know your light switch in your bath fan. We make these little controls that you can put on the bath fans, and it'll circulate them. It'll actually ask you the same question: square foot, number of bedrooms, CFM of the bath fan, and it'll run them every so often to flip some air in the house or or actually it's just, it's nice when you have like a 6-inch pipe, you got some positive pressure, but if you want to have some exhaust function, you can kind of put those together. But by far the best solution is an ERV, especially in a spray foamed house, okay? So I can dial in the pressure. So now a HRV only transfers heat. An ERV transfers heat and moisture. So unless you're in extreme Canada, I would never put an ERV in. An ERV does so much more, and it doesn't dry your house out in the winter. Yes?
I got another question from Ferris. He wants to know why when do they do heat load calculations, they ask you do you have an HRV? If yes, it'll be different BTUs. And the CFM to the house, what makes the difference?
So you're actually taking a tight house and poking a hole in it, right? So an HRV is better than a 6-inch damper that's coming in, but in the wintertime, an HRV in our market will rehumidify the house in the summer. So you actually would have to shut it off because it brings the moisture in. It doesn't transfer the moisture. So that's why they're really better in really northern cold. And when I say northern, I'm not talking Minnesota, they don't put HRV, they put ERV. Well, I guess there's some that do, but in the summertime it's bad. So an ERV is just so much better because it'll recover the heat and keep the house from drying out. But it's always gonna, when you're doing your load sizing software, anytime you introduce ventilation, you got to overcome it. So it may adjust your system a half ton more or less. Okay, a spray foamed house is going to reduce the size of the equipment, but when you add ventilation, you got to compensate for it. So that's all you're really doing is, especially if you got some good software that asks you what you're putting in and it does all that math for you. Okay, but that's a really good question because you have to transfer for that. So an HRV brings it in, rips takes in. So if you got like these really a real humid house in the middle of winter without a humidifier, like these R48 block houses they build north of us here, I've seen people put HRVs in, and in the summertime switch it to an ERV core, so they're actually not bringing in the humidity. So an ERV is better because the HRV takes the fresh air from outside, and then the heat from inside the house. Those air streams never touch. It's thermodynamic core, so it's transferring the heat. But an ERV has an enthalpy core, so it'll transfer the heat and the moisture through those membranes, and that way I'm repelling the humidity in the summer, keeping the majority of it in the winter, which is what I want to do, right?
How often do you change that filter?
You don't change this. You wash every year. The hog hair filters that's in there, you wash those every 6 months or so. There's nothing to change. You just clean it.
They're hog hair filters?
Yeah. You know, the old hog hair type. It's just to keep a roach from getting in there. You know, it's not, and some dust from outside. So that's why you got to kind of, those cells, you just run a little water. You can take an air hose and blow it out and get the dust out of there. Okay.
Square thing.
Yeah, the rectangle or the diamond shaped thing. It pulls right out. Okay. And then you might want to wipe it down in there. But these are twin variable speed fans on either side. And then in the middle there, I got a speed control that allows me to ramp up or slow down the fan speeds so I can get to keep it from being a negative pressure, I got to bring in or take out the same amount I'm bringing in. I got some guys that make them slightly positive, but you never want it to be negative. And you're going to turn your furnace on while you're setting this up. You might even want to turn your bath fans on, and then like if it's an extreme situation, you don't want to pull a negative. Now what it is not is a makeup air for the kitchen hood, right? So when you're doing new construction and the builder is putting in this 1300 CFM massive, cooktop, they're going to have the makeup air kit that comes with that thing. And if you put in this enclosed fireplace that sucks air out of the house, that's not going to overcome that. You got to put the rest of the stuff in. And so when you go to the job trailer with the builder, you have, and you got the kitchen guys there, you got the plumbers, you have meetings. You say, which one of you guys is the kitchen hood guy? Because you're putting in the vent, right? Right? On new construction, y'all run the vent rough end. So if they put in a 1300 CFM, you got to know what size pipe to hook to that thing anyway. And then you need to say, is there a makeup air kit that comes with it? Because you need to install it, because you're not pulling 3 tons of air out of my house. Because when it does, it's your fault. But it's not your fault, but it is your fault. It's actually the kitchen hood guy's fault, because the homeowner didn't want to spend the money on the proper accessory with it. You go out of the return, back into the return, and use the duct system as your delivery system. And then you have a fresh air intake and an exhaust, and they got to be 6 foot apart. Okay?
Doesn't matter how far away you run them.
Well, it does. I mean, you got to kind of, first of all, they got self-leveling straps where you hang them from the floor joist, and you pull them and they level up. Excuse me. Then we've got these duct board, the flex connectors, where you can get a good tape around, and then you slip them in and put a zip screw in to hold it. So it's just really well thought out on install. It's also got a collar within a collar, so you can put your flex around and then stuff your insulation side and get a good vapor seal around that thing. And then you take that diamond shape part out, wipe it down, clean rinse out the hog hair filters, and put it all back once a year.
The attic?
It's insulated. You can put it in an attic and everything.
You don't run water through that core, do you?
No, it's not water at all. The only reason it's got a drain on the bottom of it.
I'm talking about when you clean that square.
Yeah, you can put water in there. But you don't want to dunk it. You just want to spray it out. I always just used compressed air or nitrogen, my nitrogen bottle, and blew it out, because it's just dust that gets in there. It's not super corroded. And then you do have a drain line, and the drain line is for if you don't balance this thing properly and you're bringing in cold air from outside, you could freeze that core up. And if that core ever freezes up, it's got a temperature probe in there. If it gets to freezing, it'll shut that intake off and defrost that core, and you got a drain line that you have to put a P-trap in that drain line with water in it, because it's negative pressure, and if that coil ever freezes up, you got a way to drain it. Okay, is that cool?
You put the P-trap if you put it in the attic, you put the P-trap in the.
Well, it's never going to really have water, but you need to kind of be careful where you drain things. Okay. There's also, you just need to balance it so it's not going to freeze up. Okay. But yeah, in an attic, you got to be careful with the drain. You might have to heat tape the drain. Okay.
Could you bring it to the
Yeah, but still between there and there.
yes.
But it's got heat from the furnace coming into it, so it's keeping it warm inside that thing. Okay. And then it's an insulated cabinet too. It'll hook up with any of our controls, and it's gonna really solve the problem for that tight house. Is that cool? So we're kind of done. It's 8 o'clock. I was gonna try to get done earlier for JD, but sorry, your wife's gonna kill you. But thanks everybody. I hope you learned something. And if you have any questions, call us and we'll respond. So thanks, sir.
Yeah, thanks. Give everybody Gary a round of applause. Everybody give Gary a round of applause.